Hi, welcome to part 7 of Electromagnetic Induction. In this video, I am going to give you the solution of question number 6.5 given on page 230 of NCERT Physics Part 1. The question says there is a 1 meter long metallic rod which is rotated with an angular frequency of 400 rad per second about an axis at one end of the rod, and the other end of the rod touches a metallic ring, and this ring is placed in a magnetic field, uniform magnetic field of strength 0.5 Tesla. The direction of the magnetic field is parallel to the axis. So since B is parallel to the axis and area vector of the coil is also parallel to the axis, so we have to realize from the question immediately that the angle theta, that is the angle between B and A, is equal to 0. B is also parallel to axis. The area vector of the plane of the ring is also parallel to axis. So the theta, the angle between B and A is equal to 0. So cos theta is equal to 1. Since the question is about induced EMF, your mind should immediately go to the fact that there has to be induced EMF only when there is change in flux. What is flux? Flux is equal to B dot A, that is BA cos theta, that is equal to again BA in this case, because theta, as I told earlier, that theta is equal to 0. The angle between B and the area vector is 0. So in this case, phi is equal to B into A. Since we are talking about induced EMF, that means there has to be change in flux. Change in flux could be due to any of these reasons. Either due to dB dt or due to dA dt. Since the magnetic field is uniform, dB dt is equal to 0. That means B is a constant. So d phi dt is due to change in area. So we need to find out what is this change in area. Area dA dt is what we need to find out, because induced EMF is equal to B dA dt. Now we come back to the question. There is a metallic ring and there is a rod which rotates about an axis at one end, and the other end touches the metallic ring. The length of the rod is 1 meter, so the radius is also 1 meter. The angular frequency with which the rod rotates is equal to 400 rad per second. What is angular speed? Angular speed is equal to angular distance by time. So we need to find out what is this angular distance. We complete the loop from between OP and the rod R. So we complete the loop by joining O and P through a resistance R. And now if the rod rotates an angle theta 1 in time t, then omega is equal to theta 1 by t. This gives us theta 1 is equal to omega t. We are going to use this. So theta 1 is the angle covered by the rod in time t seconds is given by omega t. Now, in case the rod had covered full 2 pi, the area swept by the rod would have been this area, which is equal to pi r square. Okay, so now the rod is covering an angle theta 1. So the rod is covering an angle theta 1 in time t seconds. We need to know what is this area it is covering, because this is the change in area. This is the dA dt. Why we are finding out dA dt is because phi is equal to b into a, d phi dt is equal to b into dA dt. So our induced EMF is equal to d phi and d phi is equal to b into dA dt. B is constant and is equal to 0.5 Tesla. But we do not know what is the rate of change of the area. The reason why we are doing this is to find out what is dA dt. So in time t seconds, this rod covers an angle of theta 1. And as I told you, if it had covered a full angle of 2 pi, the area swept by the rod would have been pi r square. In this case, what is the area covered by the rod when it has covered an angle of theta 1? We use the simple unitary method. If the angle covered by the rod was 2 pi, the area swept would have been pi r square. R is the radius. We can use this as pi L square because we are using the resistance as small r. So you may get confused. So let's write this as pi L square. So when the angle covered is theta 1, the area covered would be pi L square. It's a simple unitary method by 2 pi into theta 1. In other words, pi L square by 2 pi into theta 1 is nothing but omega t, because angular speed is equal to angular distance by time. Simple distance by time formula. So theta 1 is equal to omega t from here. So we write this as omega t. So pi cancels and we have the area covered as L square by 2 omega t. So the area being equal to L square by 2 omega t. Area swept by the rod when it has moved a distance of theta 1 in time t seconds, the area swept by the rod is equal to this. So what is dA dt then? dA dt is equal to L square by 2 omega dt by dt. This becomes equal to 1. So you have L square by 2 omega. So d phi dt is equal to b into dAdt, which is equal to B into L square by 2 omega. So now we put the value of these. So what did we get? d phi dt is equal to B into L square by 2 omega. We put the values of B as 0.5, L as 1 meter into 1 meter by 2 into omega is 400 rad. So take off the decimal and put a 10 over here, cancel 220, so it comes to 100. So induced EMF is equal to 100 volts. In case of any doubts or clarifications, you can log on to www.olympiadtester.com/mentor. Thank you.